Right, we managed to get the multi-tone pot in. The length of the thread is slightly shorter. This is the focus on this. There we go. The length of the shaft is slightly shorter on the multi-tone pot, and so I had to turn this shaft down here, this stepped here. But it's gone in and it's done up tightly and it all looks fine. So the next thing to do is just see how well it performs now it's got a multi-tone pot on it. Right, so it's switched on. Let's see how we get now. You can see, got a nice fine control over the unit now. Why they didn't put a multi-tone pot in, I really don't know. But there we go. So we can set it to 16.8, for example, quite easily now. Whereas before it was very jumpy, you know. And it goes all the way down to 0, no problem. And all the way up to about 22, so that appears to be okay. Yeah, it goes up to 23 volts, so that's good. The next test I think we'll do is check to see how its performance is like for load regulation and things like that. So let's get that hooked up and we'll move on to the next part. So let's have a look at the load regulation quickly, see how well it works here. So the output is 2.079 volts, you can see the meter's accurate. What I'm going to do is apply a 4 ohm load across that, which will give us half an amp. And what you'll see is the current indicate around half an amp there, but what we're looking for is no change in the output. So let's apply 4 ohms, half an amp. So it's gone to 2.062 from 2.070. No, it hasn't, 2.079. So that's pretty good load regulation. Let's run it so we can actually see. So that's at a maximum load at low voltage at 16 millivolts, which is pretty respectable, I would say. So we'll try it on the 8 ohm. We'll increase the current until it reads half an amp. The voltage it reads half an amp. So we're putting close on 4 volts now. So we indicate the maximum load on the meter. Now what we'll do is we'll take the load off, so that shows 0. We'll rel our meter again. Okay, and then we'll apply the 8 ohm load, the same 16 millivolts drop. So that's pretty respectable, and that's what you'll expect to see on the other channel as well. So a pretty good performance really for like a fairly budget little or basic power supply. So let's move on to the 5 volts and see how well that does. So same thing, but obviously we won't be able to load it as much because we can only provide 6 volts. Select our 5 volt range. And get this out of it's in range hold, I think. Set rel. Okay, so 6.91 volts, which is the maximum it will do. Apply a 4 ohm load, so we're looking for a change in output. So it's 1.7 amps. We've got 40 millivolts drop, which is not bad. So it seems to be performing pretty well for sort of load regulation. The other test we tend to do at work, which I'm not going to bother with because I'm not that interested, is line regulation, how well it reacts to changing the input voltage. I could do it with a variac, but it's not of little importance to me really. So the next test, I think what we'll do is we'll just check to see what our ripple noise is, and I expect it to be minute because it's, as I said, it's a linear regulator. But let's have a look at that, see what our ripple noise looks like. Okay, this is the 5 volt rail at 1.68 amps. Every now and then you'll see a spike of noise. Now that's not the power supply, that's something picking up something in the workshop, maybe a power supply. Could be my phone polling or something like that. But you see that the ripple and noise is less than 2 millivolts, so it's very, very low. We've got the traditional, when you're measuring power supply ripple and noise, you always have a 20 megahertz bandwidth on, and that's what we got. So this is the 5 volts, very low, no ripple breakthrough, just electronic RF noise breaking through on the scope from a switch mode power supply or something. So nothing wrong with that, that's working nicely. Let's have a look at the 20 volts. Right, this is the 20 volt rail. We're running at half an amp, so 500 milliamps. Actually it's rated power. You see it's got the same sort of noise thing. There's a little bit of low frequency disturbance there, but it's regulating very well. What will be another interesting test is to increase it into current limit, see what it does then. It briefly has a jump as the fallback circuit kicks in, but it's still smooth. Sometimes they can oscillate and do some strange things, so that's fine. And it's, as I say, it's still got that burst of data, nothing, or data or whatever it is. Don't know what it is, but it's not the power supply. So that's working fine. There is one more test we can do, and that's load step change to see what that does, but we'll do that on the scope, so I'll set that up. Right, what we're going to do now is I set the scope up for single shot, so it's it will only do a sweep once it finds a trigger point. What we're looking at the response of the regulator to change from presently it's drawing 250 milliamps. I'm going to increase it to 500 milliamps by going from 8 ohms to 4 ohms, and seeing the response on the scope, and just see how quickly it responds and if it rings, or how long it takes for the loop to get back into regulation again. So I'm going to swap it over to 4 ohms now, and then back. No, it's doing nothing. Are we acquiring? Let's do that again. Sometimes it's a little bit jumpy to set these things up. I thought I had it set up just now, but obviously it's not working properly. Single sequence. It should trigger. There we go. So what you're seeing here is when I change from 8 ohms to 4 ohms, the regulator suddenly thinks, wow, there's no load, I've got to back off the voltage slightly. So that's this point here, and then you'll see this is the loop recovering it's getting its marbles back again. So that's taking 2, 4, 600, 800 nanoseconds, about less than a millisecond to get the loop back into response again. So that looks pretty good. Triggering level's probably a little bit high, that's what it is, I think. Come on, acquire. Yeah, so there you go. You can see, let's turn that down a bit. Do it again. Tricky always to get these trigger points right where it's going to trigger properly. Should be about there. Anyway, I've proved the point. It's very good at getting its loop under response again. So there's no you won't get any overshoot or undershoot with rapid load changes. So that appears to be working fine as well. So I think basically it's put it back in its box and start using it.